So the whole purpose of this is to go back and forth between rational exponents and radical expressions. Okay. So I want you to consider this. We'll start with something very, very simple. Let me get my notes out here. We'll start with this. We'll say everyone here is pretty good at following this logic. Let's start with the square root of 25 can be rewritten as the square root of 5 squared, which of course gives us the principal square root of 5, right? The square root of 25 is the number 5, okay? No one's head exploded yet. We're all good, right? We're good? Okay. That's true, okay. So I wonder, is there another way that we could write the square root? So what I mean by that is there another way that I could write this and still come up with the number 5? Well, follow this logic here, right? You all agree that 25 is 5 squared, right? And we just saw in all those properties, right, in all these crazy properties on the right-hand side there, the power of a power, and this still has to be 5, right? So what does x have to be in order to make this true? X has to be 1/2. So it must be true that the square root of 25 is the same thing as 25 to the 1/2 power. You guys agree with that? Yeah? Okay, good. Let's try another example. I'll do this right here in the same box. Is there a way, let's say the cube root of 64, right? I'll move over just a little bit here so we can all see. The cube root of 64 is the same thing as the cube root of 4 cubed, right? Which of course just gives us back 4. So is there another way that I could write this without a radical in terms of an exponent, right? So what would it have to be? 64 to the 1/3 is equal to 4, right? Okay, for the same reason. So how many of you guys already knew that already? For the most part. Okay, yeah, we kind of understand this on an easy level here. So let's move over here to the second idea. Okay, so in general, how can we summarize what we've just observed? Well, we have the nth root of x can be rewritten in terms of rational exponents as what? X to the what? 1 over n. And this is true for any positive integer. Okay? So let's do a few examples of that. We'll stay in this box for a while here. So if I have 216 all to the 1/3, this is an expression involving a rational exponent. How can I change this expression involving a radical? Well, this is the same thing as the cubed root of 216, which is the cube root of 216 is a perfect cube. Anybody know what it is? 6 cubed, very good, which of course gives us back 6. Very good. Okay? Let's do this one. What if I did 7 to the 1/2 and I multiplied that by 7 to the 1/2? What we saw on that property, right, when we multiply same basis, we add exponents. But we could also just rewrite this as the square root of 7 times the square root of 7, which is the square root of 49, which gives us back 7. Okay? All right, try this one. If we did 5 to the 1/4 and we multiplied it by 125 to the 1/4, I could rewrite this as the 4th root of 5 multiplied by the 4th root of 125, which gives me the 4th root of 625, which of course just gives me back 5. Okay, so you guys go ahead and try this 3 here. Simplify the rational exponent expressions. Okay, so yes, all this stuff in the middle, that's what we want to show. Okay, we do. Okay, so the official rational exponent here, if we're going to take note, this would be what to write down. So if we have a to the 1 over n, that's a rational exponent because the exponent is a fraction. Okay, we already just saw that that's the same thing as the nth root of a. That's the first one that we just have been playing with. All right, if we extend that to say a to the, I don't know, m over n, right, then this is going to be the nth root of a to the m, which can also be written as the nth root of a all to the nth power on the outside. Does that make sense to you? Have you guys seen this before? Yeah? One person has seen it? At least one? Okay. A few things to note here. M must be an integer, so M is an element of the integer, so M has to be an integer value, right? And M divided by N has to be in lowest terms. Where? Okay. So what we're going to do is for this fifth box here, I want you to express in radical form. So express in radical form. So that means I'm going to give you something like this that's going to be in a rational exponent. So for example, what if we did x to the 3/7? How can I rewrite this or express this in a different way that has a radical in it? All right? Yeah, what do you think?
So it's 7 square root.
Yes, this is the 7th root of x to the x to the third. Very good. The 7th root of x to the third. Okay, that one's pretty easy, straightforward. Let's do part B. What if we did y to the negative 3.5? Huh. Okay, this one's a little bit more challenging. Negative 3.5, there's no radical in there. I have a negative exponent, so I have a lot of rules I need to make sure I consider, right? So what do you guys want to do first? What's a good idea? Yeah.
Maybe convert that to a fraction.
Convert it to a fraction in simplest form. So what's the simplest form of 3.5?
-7 over 2.
There you go. So let's rewrite this as y to the negative 7 over 2. So that'd be a good first step. I agree with that. I'm down with that. Okay, now how do we deal with a negative exponent? Remember the property that we looked at earlier in the day? Yeah, the negative exponent. So that's going to be 1 divided by y to the 7 halves power. Okay, we're getting there. Does that have a radical in it yet? No, but we're almost there. Who's got a good idea? Throw it out. Mia, what do you think?
1 over radical y to the 7th.
Yeah, okay, so I think you're saying something 1 over the square root of y to the 7th. Is that what you meant? Okay, I think that's exactly what you said. And I'm with you on that. Okay, now who's got a good idea? We can't have radicals in the bottom. Yeah, Daniel. Yeah, let's rationalize it down. What do you want to multiply by? Square root of y to the 7th. I'm with you on that one. Divided by a square root of y to the 7th. Okay. And why are we allowed to do this? Because it's a fancy one. Is there a question? Let's finish this off. So what are we going to have here?
Square root of y to the 7th.
So I'm going to have the square root of y to the 7th on top divided by what?
Y to the 7th.
Y to the 7th. Okay, now we actually have to deal with that square root a little bit better. Now, so Mia, what do we got?
You do square root of y to the 2nd 3 times.
Yeah, y squared times square root of y squared times square root of y squared, but then I still have a y, right? Very good. All over y to the 7th. Okay, now, why is it important to break it up to match my indexes? What does that do for me? Yeah, so the square root of y squared is how much? That's just y, and I have 3 of those. So I'm going to have y cubed, square roots of y, all divided by y to the 7th. So that becomes y to the square root of y all over y to the what? Y to the 4th, and that is the right and final answer. Because now I have the expression that's been represented in a radical form. So expressing something in exponential form, so that means I'm going to give you something like, let's do this first one here, the square root of a to the 5th. So right now it's in a radical form. We want to express it as an exponential form. All right, so who's got a good idea? Yeah. Yeah, so the intermediate step, you could say this. This is like a to the 5th to the 1/2 power, which is a to the 5 halves. Is that what you're going to do? So there's an intermediate step there you could show. Okay, let's do B. How about what would the 5th root of b cubed end up being?
3 over 5.
Yeah, that would be b to the 3/5 power, right? You guys okay with that? This is the definition of what it is, okay? All right, let's do one a little bit more challenging. Let's take a little bit more thought. Let's do this one. Let's do x to the negative 5/8 power, okay? So this is going to take a little bit of thought for us.
Oh, it's because that's the negative.
Okay, so what do you guys want to do first? What can we do?
1 over
Very good. 1 over x to the 5/8 power. I agree. What can we do now? 1 over, this could be the 8th root of x to the what? X to the 5th. Okay, so far so good? Good. Now what can we rationalize by? We're going to multiply by what number here? Remember, we're looking for a fancy 1, and I'll go in pink here. What's it going to be? The 8th root of what? X root of 8 to x to the 3rd. Very good. The 8th root of x to the 3rd. Wait, why? Because 5 and 3, when you add them, make 8, and you want a perfect 8th root. Right? That's what you're looking for. Okay? Awesome. That right there is probably the hardest part of visually seeing what's going on in this problem. Okay, on the top, I have the 8th root of x to the 3rd. On the bottom, what do I have? I just have x, and oh my gosh, we're done. Okay, so I want you to simplify as far as possible. And work together on this, and if you have an answer, you guys can come up and write it yourselves. Write this with a rational exponent. What'd you guys come up with? Who wants to yell it out? Jake, you want to get it? What'd you get, dude? X to the 1/2. Okay, how did you get x to the 1/2? That is the right answer, by the way.
Put x to the 3/4 over x to the 2/8.
X to the 3/4 over x to the 2/8. I agree with that. Then what do you do?
X to the 6/8 over x to the 2/8 because you want to have them be like.
Oh, yeah, but we want to put them in simplest terms, right? So this would be x to the 1/4. Is that okay?
Okay.
You guys go with that part?
And then, we had 4/8 and then we got to 1/2.
Yeah, there you go. So if we're dividing two fractions with the same base, we subtract their exponents. So all of a sudden we get x to the what? 2 over 4, which means we get x to the 1/2, and that is the right answer. Raise your hand if you got x to the 1/2. Let the record show, like everyone in the room. Got it. Awesome. Nice job. Okay, same directions. Right with a rational exponent. Right with a rational exponent. Do part B here. Right with a rational exponent. Mia, tell us what you did.
First, I changed radical 3 to 3 to the 2/4 or 3.
Yeah, okay.
And then I changed square root of 4, like the fourth square root of 3 to 3 to the 1/4.
Good. Okay.
And then you just multiply.
Yeah, so if you multiply, you have to add their exponents. What would that be? 3 to the 3/4. Okay. Change this answer to an answer that has a radical expression. So right now it's in a rational exponents. Give me a radical expression for that. What would it be, you guys? The 4th root of 3 cubed, or the 4th root of 27. There you go. Okay. Okay. So there you go.